All right, so the next thing that we're going to work on is solving when you can't necessarily factor, okay, where we're going to include some irrational and imaginary solutions. Okay, so we're going to start by talking about something called the irrational conjugates theorem. Okay, so irrational conjugates theorem, irrational meaning like square roots, and conjugates, we talked about those when we looked at dividing imaginary numbers, right? So it was when you had something like 3 plus 2i, and the conjugate was 3 minus 2i. So like the same thing, but the opposite sign in the middle. Okay, so that's what conjugates are. Okay, so irrational square roots, conjugates, same thing, but with an opposite sign in the middle. So let f be a polynomial function. It's got to have rational coefficients, meaning they can all be written as fractions, so no like square roots or anything. Okay, a and b have to be rational numbers, so not square roots. And it has to be done in such a way that the square root of b is irrational. Okay, and all that means is that basically b can't be a perfect square, right? Because if it is, then when you take the square root of it, it's just a regular number, and then that defeats the whole point of what we're talking about. So b just needs to be something that you can't take the square root and get an exact answer for. Okay, if that's the case, right, then if a plus b, or a plus the square root of b is a 0, then a minus the square root of b is also a 0. Okay, so those two are conjugates, same things, but one's plus, one's minus. Okay, and that should make sense because if you think about what would happen when you were solving, the fact that there's a square root here means you square rooted at some point. And whenever we take square roots, you get a positive and a negative answer. So that's kind of where this comes from. Okay, so let's take a look at how we're going to do these problems. So we're going to start off the same way that we have. You can see I made my list of possible solutions here. Okay, and then what we're going to do is we're going to kind of use our graphing calculators to help us out. So my possible solutions, all the factors of -8 divided by the factors of 1. So positive, negative, 1, 2, 4, and 8. Okay, so what I'm going to do now is I'm going to grab my graphing calculator and I'm going to graph this function. So it's going to be x to the 4th minus 4x to the 3rd minus 2x squared plus 16x minus 8. If you need a second to catch up on graphing that, you can pause the video. All right, here's what my graph looks like. So I'm looking at this, okay, and the first thing I'm going to check is just to see if I can see all of my solutions, right? This is an x to the 4th, so I know that there's at most 4 solutions, and I can see 1, 2, 3, 4. So yeah, I've got all the possible ones. Okay, you could also make sure that you adjust your window to include all of your possible answers. So as long as my view screen goes between positive and -8 for my x-axis, I know I'd be able to see them all if they were there. Okay, so I've got all 4 solutions. So what I'm going to do is I'm going to use my list of possible solutions and my calculator to kind of like cheat. And we're going to make sure that something's a solution before we do synthetic division. Okay, so I'm going to kind of look at these and use this list to figure out what those numbers are. So like right now I'm looking at this and it looks like that's at -2, which is a number that's on my list. So I'm going to push the trace button, type in -2 and hit answer, and look, yeah, that is one of my solutions. So I know that if I put in -2, I'm going to end up with a remainder of 0 because my calculator just told me it's a solution. Okay, so that's how I'm going to start this problem. We're not done with the calculator yet. We're going to come back to that. But this is how I'm going to start. So I'm going to do a synthetic division, and I'm going to use -2 because I know that it's going to work. So 1, -4, -2, 16, and 8. So bring that down, multiply and add, multiply, add, multiply, add, multiply. And that should be 0. Where's my sign error? I made a sign error somewhere. I did something silly somewhere. I just need to figure out where it is. All right, I figured out it was a copy error. That was a -8. That should be a -8. There's my 0. I knew that it should work because I tested it on my calculator. So I knew that I'd done something silly. Okay, so awesome. So we found that that is a solution. Okay, and now from here, I could divide this out, but I'm still at a cubic and I don't necessarily know how to solve that cubic. Maybe it'll factor, but maybe it won't. So what I'm going to do is I'm going to go back to my calculator and see if I can find another one. Okay, so that cross point, that looks like it's between 0 and 1. And all the numbers in my list are whole numbers. So I'm going to skip that one because that can't be rational. This guy here, that looks like it might be at 2. So let me try 2. So I'm typing in 2, right? Trace, hit 2, right? Okay, 2 works too. All right, so I know 2 is another solution. So here's what I'm going to do. Don't go back to the original problem. Don't come back here and use these numbers again. Okay, because our goal here is that we're trying to factor this all the way. So I'm going to use these numbers, right? I factored out one number, and now I'm using what's left to continue factoring. Okay, and that's what I'm going to divide the 2 out of. All right, so that should make sense to you because think about like if you were factoring like a regular number, like if you were factoring the number 20, right? And you break this down, you say, oh, it's 2 and 10. When you go to break it down farther, you don't go back to the 20 to try to break it down, right? You pulled out the 2, now you break down what was left over after you pulled that out. Same thing here. So you don't go back to the original one, right? You factor out the number and then you take what's left and factor that. All right, so synthetic division, that's a 1. Let's hope that I can do this correctly the first time without doing anything silly. There we go. Okay, so that one worked because I had a remainder of 0. Great, and now from here, now I've pulled from x to the 4th, I pulled out 2 solutions, so I'm down to an x squared. So now I know that I'm left with x squared minus 4x plus 2, and that's something I know how to handle. So I have now factored this. I pulled out first x minus negative 2, so that's plus 2, and then x minus 2, and now this is what's left over. This guy, let's see, 2 factors of 2 that add to negative 4. Annoyingly, there aren't any, but that's all right. I can use a quadratic formula. So 4 plus or minus negative 4 squared minus 4 times 1 times 2 all over 2 times 1. Don't forget, if I'm going too fast for you, you can pause this video and go back and fill this in. Okay, and then simplify 8, so that's 4 plus or minus 2 root 2 over 2, and that simplifies to 2 plus or minus root 2. Okay, great. So what does this tell me? This gives me the rest of my solutions. So now my possible solutions are x equals, from this guy, negative 2, from this guy, positive 2, and note that those are the numbers that we divided out with our synthetic division back up at the top, right? Or this 2 plus or minus root 2. And those are my 4 solutions to this polynomial. All right, great. Next page where we have some more examples. That wasn't too bad. These ones just kind of take up a lot of space sometimes. All right, so this one, the thing that's different about this is that now I've got a leading coefficient here that's not 1. So I'm going to make my list of my possible solutions, and it's just going to be, they're going to be a little bit more complicated just because they're going to have some that are possibly fractions. Okay, so let's go through and do this one. So my possible solutions would be all the factors of 30 and then all the factors of 30 divided by 2, right? So my possible solutions, all right, let's see. So I'm going to have positive or negative 1, positive or negative 2, positive or negative 3. 4 doesn't go into 30, but 5 does. And then 6, 3 times 10, 2 times 15, right? And then 1 times 30. So it's all of those ones are my possible solutions. And then all of those divided by 2. So that would be 1/2. 2 divided by 2 would be 1 that's already in my list. Positive or negative 3 halves, positive or negative 5 halves. 6 halves is already in my list, that's 3. 10 halves is already in my list. 15 halves. And then 30 halves is 15. That's already in my list. So that's all of them. Okay, so there's my possible solutions. All right, and now I'm going to turn to my graph. I'm going to graph this equation. Okay, don't forget you can pause this video. So if I'm going too fast for you, pause it and take a second to catch up. All right, so I'm graphing this. I'm going to take a look at what this thing looks like. All right, and here's what I'm seeing. Right now, I see 2 solutions, right? So I have these 2 different solutions. But I know that there's a possibility of being 4. So it's possible that there are 2 imaginary solutions that I can't see, or there could be solutions that are off the sides of my graph. Okay, so here's how I'm going to help myself out here. I know that the largest and smallest possible solutions are -30 and +30, right? That's the biggest and smallest number on this list. So I'm going to go adjust my window and make sure that I just adjust it so that I can see negative and +30 on my x-axis. Okay, and nothing else crossed over, so I've got my solutions. Okay, so right off the bat, I know that there's 2 solutions here, and then there's going to be one that's imaginary. All right, but now I can't really see, so I'm going to go back to my normal zoom and just check out these middle guys. Okay, so it looks like I have a solution at 3. So the first thing I'm going to do is I'm going to try 3. Yep, 3 worked. Cool. All right, so I'm going to go ahead and set this up. So synthetic division using this 3 that worked. So that's 2. 2 times 3 is 6. 5, 15, 4, 12, 10, 30. Don't you love synthetic division? It's so fast and easy. I love synthetic division. Cool, all right, that's 1, but that only knocks me down to a cubic. So I gotta figure out this guy. So here's where this list comes in handy, all right? And this is why you wanna make your list of your possible solutions. That guy right there is not a whole number, okay? It looks like it's a little bit more than -3 or a little less than -3, I guess. So that's where this is gonna kind of come in handy, is this gives you a list of numbers that you can test. I'm guessing that that's probably gonna be -5 halves, right? So I'm gonna do -5 halves, just type it in like you would a fraction. And yep, that one worked. Okay, so this is where, like, when they're whole number answers, it's pretty easy to look at the graph and figure it out. But sometimes when you have these weird ones, it's going to be difficult to figure them out if you don't have a list of numbers to pick from. Now, you probably could have gotten it with this one because they're halves, right? But imagine if they were like thirds or sixths or eighths or something like that. It'd be a lot harder to pick that out. So that's where you want to use your list of possible solutions. All right, so we figured out that -5 halves is our solution here. So again, take these numbers now. Don't start over with the original one, but take those numbers. All right, and I'm going to use -5 halves. Make sure you're using that in fraction form. It's going to make your life easier. So 2, -5 halves times 2 would be -5. So that's 0. Cool, that's another 0, so that's 4. -5 halves times 4 would be -20 halves, which is -10. So great, that worked. All right, and then I looked at my calculator and I don't have any more solutions. So from here, I'm gonna have to tackle this another way. So I had an x to the 4th, and now I've knocked it down 2, so we're down to an x squared. So now I'm at a point where I know that my graph factors to x minus 3 times x plus 5 halves, and then times 2x squared plus 0x plus 4, right? That's what my thing factors to. So now I've got something that I can pretty easily solve, right? So 2x squared plus 4 equals 0. 2x squared equals -4. X squared equals -2. So x is positive or negative I root 2. Okay, and there's the rest of my solutions. So positive, negative I root 2, positive 3, -5 halves. Those are my 4 solutions to this particular equation. All right, one more to run through. So this guy, I know that my possible solutions, my possible solutions are going to be factors of 16. So my possible solutions, right, positive -1, positive -2, positive -4, and positive -8, and then 16. Okay, so those are my possible solutions. Again, I'm going to go back to my graph and graph this. Oops. That was supposed to be an 8. There we go, that's better. 24x squared, 32x, and 16. And let's take a look at this. Okay, so we got something happening here. All right, and I just want to check again. I'm going to use that same trick. I know that as long as I can see positive and -16, I'll know if I have all my solutions, right? No more, so apparently that's it. Okay, so I'm gonna go back to a regular zoom just so I can see the whole thing. Okay, so here's what I want to point out with this guy. So when I look at this graph, it looks something like this. All right, and if we kind of take a look at that spot, you want to just kind of be careful because there's two things that could happen. Either it's coming down and hitting the graph and bouncing off, or it's possible that it's like passing underneath just a tiny, tiny bit and then coming back up. So I'm going to go to my zoom menu and use zoom in, option 2. So I'm going to zoom in, just go over to around where that point is and hit enter so that we can just kind of pull it up and make sure that we can see what's happening. And yeah, like that's not crossing over and coming back up. That's one solution. All right, and it looks like it is at -2. So let's try that. Yep, it is. Okay, so that's at -2. All right, so I can go ahead and start this like normal, right? 1, 8, 24, 32, 16. And I'm going to go ahead and factor out that -2. So 1, 6, 12, -24. So that's 6. Nope, 8. -16, 0. Cool. So that worked. Okay. Here's the thing that's special about this one. Okay. Because we have this point here where it comes and bounces off, that is a special cue that you need to be aware of. Okay. So we call that a bounce, and that's literally what the math term, like what people call it. So it bounces off the x-axis. All right. And what that tells you is it tells you that there must be at least 2 solutions that are x equals -2. Okay. So x equals -2 has to be a solution more than once. Okay. And we can kind of know that based on like our knowledge of what happens with parabolas, right? When I had a parabola that was like x plus 3 times x plus 3, right? That was x plus 3 squared. And when you graph that in vertex form, right, it would look like that. So it comes down and it bounces off. Well, that's your cue that you're going to have 2 solutions there. And it kind of makes sense because if you think about it, like it's passing over twice, but like infinitesimally close together, right? So it's like it comes down and crosses over and then crosses back again, but they're so close to each other that they're literally the same thing. Okay. So what this is telling me is that this has to be a solution at least twice. It might be more than twice. It's going to be an even number of times, but it could be 4 times or 6 times or 8 times. I don't know. Right. So that's going to be kind of my next cue that I'm going to do. So because I know looking at the graph that this is a bounce, the next thing that I'm going to do when I divide, I'm going to use these numbers and I'm going to use -2 again. Okay, so 1, -2 is 4, that's -8, so that's 4, that's -8, that's 0. Perfect. Okay, and now I've got this down to a point where I am ready to handle it with my quadratics. So I've now factored this to x plus 2, and then another x plus 2, and then I'm left with x squared plus 4x plus 4. Are there 2 factors of 4 that add up to 4? Yeah, 2 and 2, right? So that's x plus 2 times x plus 2, right? So what this guy actually worked out to be is this one actually ended up to be just one like solution at the end, but it's repeated 4 times. So my only solution is x equals -2, but it's 4 different solutions. So it meets that fundamental theorem of algebra corollary that says that I would have to have 4 solutions to this if you count each repeated one as a separate solution. Okay, so that is the thing that you need to make sure you're aware of, and you got to kind of drill that in your brain that anytime you see a bounce like that, use that number twice because that's going to be a solution at least 2 times. Some even number of times it will be the solution.